Lesson 8.2, the distribution of the sample proportions, and the objectives are to be able to describe the distribution of the sample proportion and compute probabilities of a sample proportion. In 8.1, we have covered the sample mean. For it to be normal, it has to be greater than or equal to 30 for the central limit theorem to be invoked, or if it's less than 30 for the sample size, it needs to be normally distributed without any outliers. For independence, the sample size n needs to be less than or equal to 5% of the population. Mu sub x bar is equal to mu, and sigma sub x bar is equal to sigma over the square root of n. This is helpful for when we do not know the distribution or it is skewed left or right. We can get it to be normal, then we can apply what we've learned using the normal distribution. So this is why it is very helpful. And now for sample proportion, this is a qualitative characteristic or attribute. And so far we've only worked with binomials. So we're going to use this information in 8.2 so we can then apply the normal distribution to the qualitative side of this. So let's get started. So a sample proportion is denoted by p hat. Suppose that a random sample of size n is obtained from a population in which each individual does or does not have a certain characteristic. The sample proportion denoted p hat is given by p hat equaling x over n, where x is the number of individuals in the sample with the specified characteristic, and the sample proportion p hat is a statistic that estimates the population proportion p. Let's look at an example. The Harris Poll conducted a survey of 1,200 adult Americans who vacation during the summer and asked whether the individuals planned to work while on summer vacation. Of those surveyed, 552 indicated that they planned on working while on vacation. Find the sample proportion, so p hat, of individuals surveyed who plan to work while on summer vacation. So p hat is equal to x, which is your 552 over your total. It's 1,200. So it's 0.46. So we've done stuff similar to this. Let's put it in words of what this means. The Harris Poll estimates 0.46 or 46% of adult Americans who vacation during the summer plan to work while on summer vacation. So just like the sample mean, for the sample proportion, we are going to describe the shape, center, and spread. So this is very similar to what you learned in 8.1. What do you think the shape of the distribution of the sample proportion is going to be as the sample size increases? It's going to become approximately normal. And then what are the conditions? So in the sample mean, we had n is greater than or equal to 30 for the central limit theorem. For this one, we have n times p times 1 minus p, and that has to be greater than or equal to 10 for it to be normal, or approximately normally distributed. What about the center? So as the sample size n increases, what does the mean of the sampling distribution of the sample proportion equal? This is going to equal the population p. And then the spread, as the sample size n increases, what happens to the standard deviation of the distribution of the sample proportion? So very similar to sample mean. As we get more and more sample size, or as it increases, we get closer to the population. So as we get closer, the standard error decreases, which is our standard deviation. So this is going to decrease. So let's list the formulas for the sampling distribution of p hat. The mean is going to be mu sub p hat is equal to p, and the standard deviation is sigma sub p hat is equal to the square root of p times 1 minus p divided by n. And then note for independence, the sample size n can be no more than 5% of the population size, capital N. So this is what that meant. Let's look at an example. Based on a study conducted by the Gallup organization, 77% of Americans believe that the state of moral values in the United States is getting worse. Suppose we obtain a simple random sample of n equaling 60 Americans and determine which of them believe that the state of moral values in the United States is getting worse. Describe the sampling distribution of the sample proportion for Americans with this belief. So when you see it describe the sampling distribution, you should think of the shape, center, and spread. Those are the three things you need to describe a sampling distribution. So what is the shape? If we go back up here, if this is true, then we can say it is approximately normally distributed. So let's put that to work. So n is 60, p is 0.77, then 1 minus p. When you put that in your calculator, you get 10.626, which is greater than or equal to 10. So that means our shape is approximately normal. Okay, what do you think our center is going to be? So we're looking for mu p hat, which is equal to the probability, which is 0.77. This means proportion, sorry. It's equal to the proportion. And the spread is denoted by your standard deviation, so sigma sub p hat. We have p, so 0.77 times 1 minus p, all divided by n, and this should equal 0.054. All right, just for a side note, we just did the sampling distribution. As a side note, let's check the independence. So let's put this to use just so you can get an idea of what they're saying. Our sample size n was 60. It has to be less than 5% of your population size. So this is a little hard to read, so I'm going to divide both sides by 0.05. When you do that, you get 1200 is less than or equal to n. So what this is saying is your population. What's our population? Americans. So is there more than or equal to 1,200 Americans? Yes, there's about 320 million of us. So this is true, so it is independent.